Hey guys, this is Amit. Welcome to my class Python for Beginners. And you might. Okay, so last time we talked about variables, expressions, and statements, and this class number 5, is going to be all about functions. But first, I wanted to cover teeny little things about operations on strings. So I lost the Python shell and I say hello divided by 3. Does that make sense to you? It doesn't, right? Neither does it make sense to the interpreter. It says unsupported operand types for string and int. So you can't actually divide a string into 3 parts just by saying divide me by 3. But the plus operator represents concatenation. So you can say something like hello plus 2. Okay, it has to be well, it's the same thing we did again, right? We can't concatenate a string and an int. So rather, let's say something like 2 hello plus 2. This is hello 2. So a plus is an addition when it's on mathematical operands. On string, it means you concatenate both the strings together. So string A plus string B is string AB. This star operator also works in strings. So let's say A star 2, and that's AA. What does this mean? Another example, let's say you have hello times 3 generally means you want to do it 3 times, right? So it's hello 3 times. So this interpretation of a plus and a star makes sense by analogy with addition and multiplication. Just as 4 into 3 is equal to 4 plus 4 plus 4, we expect hello into 3 to be hello plus hello, which is hello. On the one hand, the analogy makes sense mathematically. On the other hand, it's different from integer addition and integer multiplication. Can you think of a property that addition and multiplication have that string concatenation and repetition do not? Okay guys, let's move on to today's topic, which is on functions. So in the context of programming, a function is a named sequence of statements that performs a desired operation. This operation is specified in a function definition. In Python, the syntax for a function definition is something like, let's open a new file, save it as file number 5, because it's a selection of 5. So the definition of a function looks something like def, use a keyword def, then followed by the name of the function, the list of parameters, you hit colon, press enter, it indents some space on the left, and there are some statements. It can be statement 1, statement 2, and so on. You should also notice the indent, guys. So this indent is actually necessary. It's one tab space, one tab indent. So you can make up any names you want for the functions you create, except that you can't use a name that is a Python keyword. Same case holds true for the naming of variables. The list of parameters specifies what information, if any at all, you have to provide in order to use the new function. There can be any number of statements inside the function, but they have to be indented from the def. Def is the Python keyword. In the examples I'm going to teach you, I use the standard indentation, which is equal to 4 spaces. Function definitions are the first of several compound statements compound statements, we will see all of which have the same pattern, which is a header which begins with a keyword and ends with a colon, a body consisting of one or more Python statements, each indented the same amount, 4 spaces, Python standard. In a function definition, the keyword in the header is def, which is followed by the name of the function and the list of parameters enclosed in parentheses. So, in case of an actual function, this will look something like AB, and let's say A equals 4, B equals 6, we do a print 5A times B. So this function has 3 statements. So in a function definition, the parameter list may be empty. So you can have nothing here. You can call a function multiply, and then you do some things. We are finding this do nothing, and but this actually doesn't do anything because we didn't call the function yet. This is another concept that you guys must understand, that you have a function definition ready, but you haven't actually called that function, right? So it's something like you have assigned a particular guy, let's say the guy named John, to do some task, to carry out some task, and John is ready with this capability of carrying out the task, but you haven't actually called out to John yet to do that task. Similarly, in the case of functions, I have a function ready which does something, but I have not actually called out that function. So the parameter list may be empty, or it may contain any number of parameters. In either case, the parentheses are must. So the first couple of functions we are going to write have no parameters. So the syntax looks something like say hello, nothing, and we print hello. Okay. So defining a new function does not make the function run. As I told you, we need to make a function call. So function call contains the name of the function followed by the list of values called arguments, which are assigned to the parameters in the function definition. So in our older function, we said multiply A, B, and we multiply A and B. So in a function call, notice the intent here, guys. Multiply function call is on the left border. So multiply, and you pass the arguments 4 and 5. So it's like 4 and 5 are the arguments to the function multiply, and in the definition of multiply, A and B are the parameters. So parameters and arguments are related, one-to-one correspondence. Okay, so the example say hello does not have any parameters, so the function calls do not have any arguments. So you just call the function say hello by writing say hello, and you press F5 and says hello. So let's move on to a little more complicated example, which is def say hello twice. And what you do here is you call another function from this function, and now you call the outer function hello, hello, hello. So this is another thing that you must know, that from one function we can call other functions. So in our function say hello thrice, we call the say hello function 3 times. So this function say hello thrice contains 3 statements, all of which are indented by 4 spaces. So the next statement is not indented, it's not a part of the function. So this statement is not indented, it's not a part of this function. All the statements inside the function definition of say hello thrice will have 4 space indent. or maybe more, but at least a 4-space indent. This one is an outer statement, and it's a call to the function. You should note a couple of things about this program. You can call the same procedure repeatedly. So you say hello thrice, and you want to do it again, and you want to do it again. So it will print you hello 9 times. Okay. And you can have one function call another function. In this case, hello thrice calls hello once. So far it may not be entirely clear why it is worth the trouble to create all of these new functions. Actually, there are a lot of reasons. This example demonstrates creating a new function gives you an opportunity to name a group of statements. So logically you say hello thrice, and actually what you do is you call the function say hello 3 times. Makes sense logically. Functions can simplify a program by hiding complex computation behind a single command. So a single command is say hello thrice, and what it does is it prints hello 3 times rather than you issuing 3 print commands. And functions can simplify a program by hiding complex computation behind a single command and by using English words in place of arcane code, thing we talked about just now. Creating a new function can make a program smaller by eliminating repetitive code. For example, when we wanted to print a hello 9 times, we just called say hello 3 times. As you might expect, you have to create a function before you can execute it. So you can't just have what's this, what does this do. You can't have a function called to what does this do, so you have actually defined the function what does this do, and it will give you an error. Name what does this do is not defined. The interpreter doesn't know what you want from this thing. You haven't actually defined this yet. So the next important topic is a flow of execution. So in order to ensure that a function is defined before its first use, you have to know the order in which the statements are executed. This is called the flow of execution. Execution always begins at the first statement of a program. Statements are executed one at a time in order from top to bottom. Function definitions do not alter the flow of execution of the program, but remember that statements inside the function are not executed until the function is called. So until the function say hello thrice was called, we didn't get a hello printed 3 times. Okay. Function calls are like a detour in the flow of execution. Instead of going to the next statement, the flow jumps to the first line of the called function, executes all the statements there, and then comes back to pick up where it left off. That sounds simple enough until you remember that one function can call another. While in the middle of one function, the program might have to execute the statements in another function. Or while executing the new function, the program might have to execute yet another function. Fortunately, Python makes your life simple by keeping track of where it is. So each time a function completes, the program picks up where it left off in the function that called it. When it gets to the end of the program, it terminates. So what is the moral of all this tale I told you? When you read a program, don't read it top to bottom. Instead, follow the flow of execution. So you can have a program like say hello, then a say hello thrice, and let's say you want to put a bunch of statements here. Print hi, then print a 3 plus 5, and you say you want to call say hello thrice, and then you say I'm done. Go ahead 5. Understand the flow of the program. The function definitions are the first statements you encounter, but then they will be executed only once they are called. So you move down, keep coming down until you see print high. So high gets printed first. Next you see print 3 plus 5, which is 8. Now you call the function say hello thrice, and it calls say hello one time. It prints a hello. The next statement of say hello thrice is say hello. So it again goes to the function say hello, prints a hello, comes back to say hello thrice. The third statement of say hello thrice is a say hello. It goes to the function say hello, prints a hello, comes back to say hello twice. There's nothing after the third call to say hello in the function say hello thrice. So say hello thrice terminates. Then your program moves to this print statement, print I'm done. It prints I'm done and then terminates. So guys, this is the flow of execution. So we got one last topic, or one or two topics maybe, and it's about parameters and arguments. So there are, functions that take one argument. They can take 2 arguments, 3 more, any number of arguments for that matter. So let me just tell you about some inbuilt Python functions, like the absolute function. So this is the mathematical absolute function. So if we say absolute number of 5, this is -5. There's the inbuilt power function. So if you say power to 4, it will calculate the 4th power of 2, which is 60. So the function pow takes 2 arguments, which are 2 and 4, and calculates the power of 2 and 4. Power of 2 and 4 by power 2 and 4, I mean the 4th power of 2. The power of 4 and 2 would be 16. There's another function, the max function. The max function takes any number of arguments. So you can say max of 1, 1 plus 2, 2 into 3, 2 to the 4, and it's 16, because there's another thing you must learn here, that arguments have been provided in the form of expressions. That's also legal, guys. So max takes 4 arguments, which is 1, 1 plus 2, 3, 2 times 3, 6, and 2 raised to the power 4, which is 16. And max prints out the max of all these numbers, which is 16. Okay, so you can combine functions as well. So let's say you have a program which looks something like print twice, and you pass a parameter to it. This is just a variable name, guys. We use a and b in multiply. Here we are saying it's param. This is just a variable name. It's a parameter of this function. So you want to print param, and then you call it by saying print twice. First I'll say I pass a string high here. Let's see what happens. It prints high and high. Now there's something called a function composition. So you can pass another function to it, and abs of -5 is passed on to as an argument to the function print twice. It's simple enough. It first evaluates the absolute of -5. This value is then passed as argument to the function print twice. So not surprisingly, the output is 5 and 5. Guys, let's move on to the last topic in this lecture, and that's the scope of variables. A little bit about the scope of variables. So the variables and parameters are local when you create a local. So when you create a local variable inside a function, it only exists inside the function and you cannot use it outside. For example, let's say you have the function add, and you say a equals to 5, b equals to 3, and you print a plus b. You call the function add, here at 5 it says a, but if you want to access the value a, let's say So you want to print A. Give you an error saying A is not defined. So this means all of the variables which you have created inside a function are local to that function. So when a function terminates, these values are vanished. So when even this doesn't work, A is not defined. So this means that these values A and B were created inside the function, and when the function terminated, these values have vanished. You can't access these values from the outside. Another thing is, let's say you want a function add. Let's say this time I'm having a value x equals to 4, y equals to 5. I'm calling add on x and y, and so this is A and B. So now we want to change these. Actually, I don't want to print the values which we got. I just want to print some random thing. Okay, and now I want to print x and y. So you might think that the values x and y will pass to the function add, and these values are referred now to as A and B, and when we change them, the x and y change as well. It's not like that. Thing is, you have values on the outside x and y, and you call the function add on these values. So these values will be, so when the function is called to the function add accepts two parameters A and B. The values of A and B are now the values of x and y. So A has 5, A has 4, and B has 5. But inside the function definition, you change the values of A and B, but the values of x and y remain the same because those are outside of the function, whereas A and B are inside of the function. So when the function add terminates, A and B have vanished, x and y remain the same. Let's see. So it takes the value 4 and 5, you call add on 4 and 5. Till this line A is 4, B is 5, because these are the values x and y respectively. But now you change A and B, so A is 5, B is 10. Then you print A and B, it's the sum of A and B, which is 15. But now you turn back after this line add x plus 5. You want to print x and y, and x and y are unchanged, they're 4 and 5. So guys, that's about it for the 5th lecture, and I'll see you now next time. Take care.